In this third carbon-14 example problem, we're again going to be solving for the age of an organism, but in this case we do not know the decay rate of the organism. We know the fraction of original carbon-14 remaining. Here we are working with a sample of kauri wood, and kauri wood is a wood type found in New Zealand that has been buried in bogs for up to 50,000 years and is still very much intact and is used for a number of different items if you're willing to pay for it, including this bowl you see here, or guitars and other things. Okay, so let's start this problem using the information we know and want to know. What we're trying to find out here, it says, what is the age? So there's our question. What is the age of this thing? Next, we are given a fraction. In this case, we see 1/16 as the fraction of carbon-14 remaining. Whenever you see a fraction in these carbon-14 problems, you immediately want to associate that with the equation 1 over 2 to the nth, which tells us the fraction of material left after a certain number of n half-lives have gone by. In this case, we also know that the half-life of carbon-14 is 5,730 years. Using this information now, we should be able to solve for the age of this bowl. So if we want the age equation we know is T1/2 or half-life times n is equal to the age. The half-life we know is 5,730 years, but in this case we do not know the n number of half-lives or the age of the object, so we can't solve this equation all the way out yet. We are going to have to use some other information in order to get that n to solve for the age. So I hope you can see that that will probably come from right here. We know that 1 over 2 to the nth is equal to 1 over 16, so by extrapolation here we know that 2 to the nth must be 16. This is an exponent n, and so we need to figure out how many times we have to multiply 2 by itself in order to get 16. So this is pretty easy to do, I think, in our heads, but I'll write it out. 2 times 2 is 4, times 2 is 8, times 2 is 16. So what this tells us is our n is actually equal to 4. So we're going to take that information and plug that into the equation that we first started with. So here we had the 5,730 years as our half-life, and now we know the n is 4, and that will allow us to solve for the age. So we're going to multiply 4 times 5,730, and that comes out to 22,900 years. And that will be the age of our bowl.